Hi, this is Dr. David Branham. Today, again, we're going to do a chapter video. I want to remind everybody that the video is supplementary in that it's not meant to replace your reading of the chapter, but it is meant to help you in reading it and understanding the material. The video also is pretty comprehensive and it covers a lot of what you're going to see on the test. So it should be very helpful for your test score. So let's get started by sharing the screen and go into the PowerPoint presentation. As I said, this is on chapter 5. Chapter 5 focuses on research design. So we're going to go forward on that. Research design is basically a blueprint for empirical research. Remember, empirical research deals with statistical analysis, numerical analysis, and so forth. So this blueprint for empirical research is aimed at answering specific research questions or testing of specific hypotheses. And a research design outline describes this data collection process, how you're going to collect the data, the instrument development process, and the sampling process. Now, key attributes of a research design are the quality of the research designs can be defined through 4 key design attributes. And we're going to focus on these throughout the first part of this video. So these key attributes are 1, internal validity, 2, external validity, 3, construct validity, and 4, statistical conclusion validity. These are the 4 things that you want in all empirical research, where we have numerical statistical analysis. These are the things we're looking for, and you want to heighten these types of validity in all of these analyses. So let's go over these one by one. Internal validity examines whether the observed change in a dependent variable. Remember, the dependent variable is the variable that will change as a result of the independent variable. For instance, if your dependent variable is whether or not a person's going to vote, your independent variable could be something like the weather that day. If the weather's nice, people will vote. If the weather isn't nice, then people will not vote. So the independent variable is the weather. The dependent variable is whether or not you would vote. That's an example. So don't mix up independent and dependent variable. So internal validity examines whether the observed change in the dependent variable is actually caused by the corresponding change in the hypothesized independent variable and not by variables that are extraneous to the research context. For instance, you may hypothesize the weather will have an effect on whether or not people vote. But it could be other things, for instance, how far it is to the polling place. So you want to make sure that if you have these extraneous variables, that they are not the reason why the dependent variable changed. So you need to control for this. So you want to basically establish causality, where the independent variable is having an effect on the dependent variable. Now, causality requires 3 conditions. 1 is covariation. A change in the independent variable will result in a change in the dependent variable. And if the independent variable doesn't change, the dependent variable will not change. So if cause happens, then effect will also happen. And if cause does not happen, effect will not happen. The second thing you need is temporal sequence. Basically, you need to have timing where the independent variable changes before the dependent variable changes. If the dependent variable changes and then the independent variable changes afterwards, it couldn't possibly be the independent variable having an impact on the dependent variable. You need that temporal sequence where the change in the independent variable happens before or at the same time as the change in the dependent variable. And the 3, no plausible alternative explanations can actually explain the change in the dependent variable. So if the weather is impacting whether or not a person votes, the length of travel to the polling place may be an alternative explanation. So you'll need to be able to control for that to make sure that that isn't what's actually going on here, and it is the weather that is changing whether or not people go and vote. So that's internal validity. The validity of the experiment itself is sound, in that we see that change in the independent variable impact the change in the dependent variable. Internal validity, certain research designs such as laboratory experience research designs such as laboratory experiments are really strong in internal validity because they're designed to establish causation and take out all the other possibilities that may occur. But in order to have the ability to do an experimental design, you need you have to have an independent variable that you can manipulate via a treatment and observe effect on the dependent variable of that treatment after a certain point of time. So to explain this, you need to first have an independent variable you can change. Now, my previous example on the weather impacting whether or not a person can vote, it does not lend itself to experimental design because it's impossible for us to manipulate the weather. We can't change the temperature outside from 100 to 80 degrees. We can't change sunny to rain. And because of that, we cannot manipulate the independent variable. And it makes it impossible to have true experimental design in that case. You also have to control for the effects of those extraneous outside variables that could cause an impact on the dependent variable. In experimental design, this is typically done through random assignment to a control group and the treatment group. So one group will have no treatment, the other group will have treatment. Whether or not you're in that group, it depends completely on random assignment. Nobody gets to pick which group they're in. So that's one way of establishing that those two groups are equal is by random assignment. If you have 200 people and you randomly assign 100 to each group, theoretically, those two groups are equal because the random assignment takes care of all outside variables. Then your manipulated independent variable can be given to the treatment group and not to the control group. And then you can monitor the change in the treatment group and compare it to the treatment in the control group. And you can attribute that change to the independent variable. It's very handy and nice, the internal validity that comes with experimental design. So with random assignment, you can assume equal groups. I mean, that is key to say, okay, these two groups are perfectly equal. If we administer the independent variable to one and not the other, we can attribute the change on the dependent variable to that independent variable. Other designs, such as field surveys, are poor in internal validity because of their inability to manipulate the independent variable. We can't have that cause and effect determination, and because cause and effect are measured at the same point in time. Now, sometimes that occurs where a cause and the effect occur at the same time. So that can happen, but you are limited in your field surveys. You can't manipulate your independent variable and say, okay, we're going to change this. So in a field survey, you can look at the weather and the whether or not people vote and see they're happening at the same time and see if there's actually a correlation there. This makes it equally likely that the expected effect might have influenced the expected cause rather than the reverse. So sometimes you have correlation and people say, well, correlation is not causation. That's correct. Because if you are getting movement, well, if one variable moves, the other variable moves, and it's happening at the same time, you don't know if it's variable 1 impacting variable 2 or variable 2 impacting variable 1, or some third variable actually coming in and doing it, because you can't assume the two groups are equal and manipulate the independent variable. For instance, in a classic example of this is the churches and bars example, where it's shown that cities who have more churches actually have more bars. So you can come to the conclusion that the more churches you have, the more people want to drink, and that the more bars you'll have. Or you can actually, because they're actually happening at the same time, you can turn that causation around in your hypothesis and say the more bars you have, the more churches you have. So we have a problem with causation. We have a movement where the more bars you have, the more churches you have, but you don't know if one is causing the other. Or if there's a third variable. Well, guess what a third variable may be? The population of the city. It could be that higher population causes more churches and more bars. So I'll actually have a third impact creating the causation. So this correlation does not establish causation is a factor in your internal validity. So because these things are happening simultaneously, the only way you can't really establish this association causation, but sometimes, problems with internal validity and association can be eased with just common sense assertions. For instance, there's a high correlation between smoking and lung cancer. It's probably a pretty good determination that lung cancer isn't causing you to actually smoke. It's actually probably the opposite way on the causation, where the smoking is actually causing the lung cancer. One thing that cigarette companies argued for a long time was that there was a third variable out there that was causing you to both want to smoke and to get lung cancer. And it wasn't the cigarette causing it. There was this third variable causing you to want to smoke and causing you to get lung cancer. And they never could establish what that variable might be. I mean, it was completely up in the air, but they were trying to use this association issue to say that there's a flaw in the system. There's a flaw in establishing causation here. So internal validity is harder in field studies. Although higher in internal validity compared to other models, laboratory experiments are by no means immune to threats of internal validity and are susceptible to things like history, testing, instrumentation, regression, and other threats. Things happen in the laboratory that harm internal validity. For instance, it may be just the room that you put people in. If you are, for instance, establishing that one teaching method is superior to the other, and you take 200 students and you randomly assign them to two different rooms, and you have one teaching method in the one and one teaching method in the other, that's an experimental design that is trying to test and establish that teaching method has an impact on the dependent variable, which may be the ability to learn. But when you put them in two separate rooms, it could be that the room itself is having an impact on ability to learn. Maybe one room has windows, or maybe one room has too much noise. There are all kinds of little things that can happen in experimental design that harm internal validity. So it's not foolproof. It's just the gold standard when it comes to establishing causality, because fewer things can go wrong in experimental design than in other things like field studies. Now, external validity, the second kind of validity, refers to whether or not observed associations can be generalized from sample to population. That means, can our results here actually be thought of as results that are actually happening in our society? Survey research, where the data is sourced from a wide variety of individuals, firms, and other units of analysis, tends to have a broader generalizability than laboratory experiments, where they're artificially contrived treatments. I mean, it's not real world in the laboratory. Things happen in a laboratory in a certain way. When you go outside, they don't happen the certain way. A laboratory like a university, people behave differently when they're in their university than when they're in the outside world. So to generalize behavior inside a university to the outside world is problematic. There's an external validity issue. So if we do an experimental design in the university in that controlled setting, once you get out of that controlled setting, people may act completely different. And so that's an external validity issue. A survey research, there's less chance of that because you're actually addressing people while they're in their environment. They're more likely to say and do what they would normally do in these situations. That's the reason why case studies, field experiences, they have more external validity than experimental design. Constructive validity examines how a given measurement scale is the theoretical construct of what is expected to measure. So constructs in social science research, we've talked about this in the previous chapter video, things like empathy or dogmatism or prejudice, they're very difficult to measure. First, they're difficult to define, and then they're really difficult to measure. So construct validity looks at whether or not that measurement scale is actually measuring what you say it's measuring. And in social sciences, this is a very important thing. For instance, construct validity must assure that a measure of empathy is indeed measuring empathy and not compassion. Oh, you might say, wait a minute, there may not be much difference between empathy and compassion. And what you're going to have to do first is establish that difference in a definition, because you'll have a definition of empathy and you'll establish that it's not compassion. And then you're going to have to establish that your measurement is measuring empathy and not compassion. This is very difficult. So construct validity is a problem in social sciences, and it's a problem that most researchers who use these constructs in their research need to address and need to work on very diligently. The last validity, statistical conclusion validity, examines the extent to which conclusions derived from a statistical procedure are valid. Was the right statistical method used in your hypothesis testing? There's times when you run into this. You'll get into this a lot more in your statistics class, assuming you have not taken that class yet. Maybe you have. You've talked about the right statistical methods that you can use to establish this statistical conclusion validity. Do the variables used meet the assumptions of the statistical test? For instance, I've used the ordinary least squares regression example in the previous chapter video. That ordinary least squares regression has assumptions. For instance, you have to have a continuous dependent variable, that is more than just categorical. Like, for instance, whether or not you voted. That's a categorical variable. It's only 1 and 0. It violates the assumption of ordinary least squares regression. That means that you're going to have problems making conclusions out of a regression in that situation. So that's the type of validity we're talking about here. You need to do the right statistical test, have the right statistical procedures, and so forth. Now, improving internal and external validity. The best research designs are those that assure high levels of both internal validity and external validity. And these designs do a couple things. One, they guard against these spurious correlations, like the churches and bars example. People assuming that more bars are causing people need to go to church, or more churches are causing more people that need to go to bars. And the reality is it's just high population in the city. So you have to guard against these spurious correlations in order to have these both internal and external validity. And you have to ensure that the results drawn from a small sample are generalizable to the population. This is the external validity issue that experimental designs have. So if you want to have high internal validity and high external validity, you have to take care of these two things. Controls to assure internal validity or causality of research designs. 1, manipulation. In manipulation, the researcher manipulates the independent variables and compares the effects of the treatments against a control group where the subjects do not receive that treatment. This is classic experimental design. And if you have the ability to manipulate an independent variable that you're hypothesizing has an impact on a dependent variable, you almost certainly should use experimental design and have this gold standard of an internal validity on your research. As stated earlier, the control group and the treatment group should be always assigned randomly. If you have random assignment, regardless of what your group is. If you have random assignment, you're able to assume that both of those groups are equal. And then when you can give the independent variable to the treatment group, you can assume any changes and differences between the treatment group and the control group are attributed to the independent variable. Second thing you need is statistical control to control for outside influences. Extraneous variables are measured used as covariance during the statistical testing process. So if you wanted to have if you're doing the churches and bars analysis, what causes you to have more churches? You should put the population in there as a control variable. If you think bars actually cause more churches, first you have to control for population. So you can standardize this, churches per population and bars per population, and then see if you still have that correlation. That will help you establish more validity, internal validity in your work. Okay, popular research designs. We've talked about them so far, but the four that we're going to talk about and just cover it for the end of this chapter are experimental design, field surveys, case research or case studies that are more commonly called, and focus group research. Now, experimental design are those studies that are intended to test a true cause-effect relationship hypotheses in a tightly controlled setting. And it's tightly controlled because you want to make sure that your control group and treatment group are equal and that there isn't any outside influences going on that has an impact on the dependent variable instead of your independent variable. So in a tightly controlled setting, by separating the cause from the effect in time, that means you administer the cause to one group of subjects, the treatment group, but not to the other, the control group, and observe the mean effects differences between the two groups. Complex designs can also be used, which may include multiple treatment groups versus a low versus a high dosage of the drug. For instance, you may have two treatment groups. You may have a control group that gets no drug, a treatment group that gets a low dose of the drug, a second treatment group that gets a very high dose of the drug. All three of these groups, you must have random assignment where everyone has an exactly equal chance of going in. There's no selection where they say, okay, I'll be the drug group and so forth. As a matter of fact, you're better off if it's blind, where people do not know how much, whether they're in the group or not. And you can do this a lot of times with a placebo, where you take 3 pills. One is a low dose, one is a high dose, and one is a dose of nothing. And each person in each group gets their pill, not knowing whether they're getting a high dose, a low dose, or no dose at all. So these complex designs can be implemented in your experimental design. In a true experimental design, just a reminder, subjects have to be randomly assigned between each group. This allows the researcher to assume both groups are equal, with the exception of the treatment. And laboratory experiments tend to be stronger in internal validity because of that controlled environment. But those same field experiences tend to be those field experiences where you're actually out in the field and not in that controlled setting, those field experiences tend to have more external validity because they're in real world settings. Field surveys are non-experimental designs that measure variables and test their effects using statistical methods. Field surveys capture snapshots of practices, beliefs, or situations from a random sample of subjects in a field setting through a survey questionnaire. Well, one classic field setting is the exit polling. If you're a voter, you may have a person come out as you exit and ask you, who did you vote for? That is a classic field survey, and where you're coming out, they're finding out who you voted for, and then they'll ask you other questions about yourself to see what factors are determining how you vote. That's a classic field survey. Now, establishing causation, where you're saying, well, the fact that he's a man caused him to vote this way, is difficult to do because you're not getting that experimental design. You can't manipulate somebody's gender, but because you can't really do it in a controlled setting, you take your association settings and you can establish causation basically through logical conclusions. Like, obviously, how you vote doesn't change your gender, but your gender could change how you vote. Case research. Case research is an in-depth investigation of a problem of one or more real-life settings over an extended period of time. This is the classic case study where you're really looking at things closely. You collect these data by using a combination of interviews, personal observations, internal and external documents. They usually take multiple days to do. The strength of this research method is its ability to discover a wide variety of social, cultural, and political factors potentially related to the phenomena you're actually studying. It gives you a lot of external validity. Internal validity and causation, almost impossible to establish here, but you can logically assess these just like other field studies. But these give you a broad picture, sort of an explorational picture. So interpretation of findings maybe depend on the researcher themselves, because it's usually one researcher basically saying this looks like this looks like this, and you see that perspective. Findings, though, may not be readily generalized to other set case sites because you are in an environment. I mean, it does help that external validity, but you don't get to move to other environments or ask people from other environments what they're doing, because you're really looking at one setting, one snapshot of what's going on with extreme detail. Focus group research, the last research we'll go over, is a type of research that involves bringing a small group of subjects, typically 6 to 10 people, into one location, and you put them at a table, make them comfortable, try to develop a nice atmosphere, and you keep them there for an hour and a half, 2 hours, and you ask them questions. You get their feedback. The discussion is moderated by a trained facilitator. So you'll have one person leading everything, and that facilitator, one, sets the agenda, then creates a set of questions for all the participants, and then makes sure that the ideas and experiences of all the participants are represented. This is difficult because in a lot of cases in a focus group, you'll have domineering people who will do 60, 70, 80% of the talking. A good facilitator makes sure this doesn't happen. Make sure that everybody's opinion is heard, and it's important to develop an environment where people feel comfortable expressing themselves. Attempts to build a holistic understanding of the problem situation based on these comments and experiences are the real goal of the focus group. And you'll see that people will change their mind when they hear other opinions. They'll start developing opinions because they realize that the situation isn't exactly what they determined it would be when they initially got the questions. So these are very popular, especially among businesses. Businesses really like to do these, but they do have issues with internal validity. You can't really establish any controls, so you can't really establish any causation. And the findings are probably not generalizable to the outside population because they're in that room, that controlled environment. So it's going to lack some external validity on generalizing findings. But since they're not generally used for explanatory or descriptive research, they're really good for exploratory research, where you actually develop a lot of theoretical questions out of these. So they are highly valuable from that sense. So I hope that this video helped you with your test questions, your understanding of the chapter itself, and I do believe that it will help you with both of those. Please let me remind you to shoot me an email if you have any questions. I'm happy to answer your questions by email, have a Zoom meeting, and telephone call, whatever you need to do to help you in the class. Have a good day. Thank you for watching the recording.